So this is our lesson master 7.6, and it says for numbers 6 through 8, graph to find the zeros. That's part A. And then part B, factor to find the non-real zeros. That's part B. Because we can't just use quadratic formula because these are not quadratics. This is an x cubed, this is an x to the fourth. So let's start off, like it said, let's graph and find our real zeros. So I've got x to the third minus 6x squared plus 13x. And it's the best way for you to do this is to actually follow along and be doing this on your calculator. I have a standard window. Let's see if I can see this graph. Okay. All right. So let's look and see which zeros I can actually see. It'd be kind of nice to get a little closer. I can't really tell if this goes through once. Well, I guess it would have to, because if it went through twice, then there'd only be, well, I guess that could happen. Let's just see. I'm assuming this goes through once. Let's do second trace. Find a zero. Two zero, which means that x minus 2 is a factor. So when we know a factor, we're going to take x minus 2 and divide it into x cubed minus 6x squared plus 13x minus 10. And we should get a remainder of 0 since this is a factor. Focus on the first. There's no placeholders I need to put in. X cubed divided by x is x squared. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. I'm going to subtract, and since I'm going to subtract, remember I changed my signs. I've got my red pen here. That becomes a minus, and that becomes a plus. Add these up, and I get negative 4x squared, and I carry down the 13x, and I focus on the first. Negative 4x squared divided by x is negative 4x. Multiply the negative 4x by both of these. I get negative 4x squared plus 8x. Since I'm subtracting, I change my signs so that I can simply add. These cancel. 13 minus 8 is 5x minus 10. I carry down the negative 10. Focus on the first. 5x divided by x is 5. And I get 5x minus 10, which will give me that remainder of 0 that I was expecting. Now, this right here is going to give me, like it said, factor now to find the non-real zeros. So since there's only one 0 that I can see, and there have to be 3 answers because this is an x to the third, my other 2 answers must be here as part of my complex answers. So I'm going to need to use the quadratic formula. That's how I find complex answers. B equals negative 4, and C equals 5. So x equals opposite of b, plus or minus b squared minus 4 times a times c all over 2 times 1. So x equals 4 plus or minus, I get 16 minus, this is 20, so I get negative 4 divided by 2. X equals 4 plus or minus, the square root of 4, negative 4, I'm sorry, is 2i, because the square root of 4 is 2, and the square root of the negative 1 is I, all divided by 2. Now, all of these can be divided by 2, so I'm left with 2 plus or minus I. So I have x equals 2 plus I x equals 2 minus I. And then I had up here in part A, my real 0 was x equals 2. So notice, from part A, I have x equals 2. That's my real 0 that I saw on the graph. And then these are my two complex zeros that I found using the quadratic formula. Okay? Let's go through another one. I'll just kind of get you started on number 7. All right. So I'm going to go back to my graph. I always have to start with my graph. And I'm going to go to y equals and type in x to the 4th minus 6x to the 3rd plus 14x squared minus 16x plus 8. Let's graph that. All right. Can't really tell if there's how many are there. I'm gonna try and get a little closer on my window. So maybe make this -5 to 5. And I want to see. I can't tell if it dips below at all or if it hits right on there. So I'm going to have to, it's just kind of hard to see. So let's see if I can get a little, if I could get a little bit closer to that part. I'm going to, I'll just keep trying to get my window a little bit closer. How about, let me see that again. Let's go, I'll go from -1 from here. How about from 0 to 3? Let's try that on the x-axis. All right, and let's change my y from -2 to 2. I just really want to see up close. Maybe if yeah. Right, it kind of looks like it might hit there twice. I can't really tell. Let's see. Second trace. Let's find a 0. Okay, I know I'm definitely to the left of it. Now let's go. As soon as I get into the negatives, okay. Huh. I'm waiting to get into the negatives. Alright, so if you notice, every time we go to second trace and 0, I can never get my y value to be negative. It gets really, really close. And that doesn't mean a negative, that just means a whole lot of decimal places. And then it starts getting bigger again, which means it never drops below. It means it must have a 0 right on the axis, right there at 2. 2 must be a 0. And if I'm not sure, it looks as if, according to my graph, that it hits right there at 2. So 2, 0 appears to be a 0. If I'm not sure, I'm going to check it. What is 2 to the 4th minus 6 times 2 cubed plus 14 times 2 squared minus 16 times 2 plus 8? Let's make sure that it truly does hit there, because it looks like it does on the calculator, but the calculator isn't allowing me to find the 0, because in order to find a 0, I have to have it drop below the axis. So let's check. I'm going to go to my 2 to the 4th minus 6 times 2 to the 3rd plus 14 times 2 squared minus 16 times 2 plus 8, and I get 0. So yes, this right here is a 0. The only problem is that would then leave me with 3 complex solutions. Well, my complex solutions always come in pairs, which means this 0 right here must have a multiplicity of 2. There's no way that this can only happen once, because then I'd be left with 3 other solutions that would have to be complex. And complex solutions, let's write this down, complex solutions come in pairs. So, in order to find the complex solutions, the real 0 must have a multiplicity of 2. Means it must occur twice. So the factor x minus 2 must occur 2 times because complex solutions come in pairs. And this gives us, when I FOIL this, x squared minus 2x minus 2x plus 4. So this gives me x squared minus 4x plus 4. So when I go to divide, that's what I'm going to divide by. And that is going to get divided into x to the 4th minus 6x cubed plus 14x squared minus 16x plus 8. I have no placeholders that I need to put in, so I focus on the first. X to the 4th divided by x squared is x squared. Multiply this by this trinomial, I get x to the 4th minus 4x cubed plus 4x squared. Going to subtract. So I'm going to change all my signs. I get negative 2x cubed plus 10x squared. Carry down the minus 16x. Focus on the first. Negative 2x cubed divided by x squared is negative 2x. Take the negative 2x and multiply it. I get negative 2x cubed plus 8x squared minus 8x. Since I'm subtracting, I have to change my signs. And I get 2x squared minus 8x plus 8. Focus on the first. 2x squared divided by x squared is 2. Multiply the 2 by this trinomial and I get 2x squared minus 8x plus 8, which is what I wanted to happen. I wanted to have no remainder because this is a factor. So now to find my complex solutions, I'm going to use the quadratic formula on this trinomial. And I'm going to let you guys do that part on your own. So you're going to use the quadratic formula to find the 2 non-real or complex solutions. And again, remember, this one had to have a multiplicity of 2 because my complex solutions always come in pairs. And I would have only gotten 2 from this and 1 from this. That would have only made 3 solutions, which means this had to occur twice.